Let us learn to lead. Welcome back to the video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra. Dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to verify the result, parallelogram by joining the midpoints of the sides of a quadrilateral. When you join the midpoints of the sides of a quadrilateral, you will get a parallelogram. We will verify this result. For preparing this video lecture, I used Windows 10 operating system, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be trying to design. Parallelogram by joining midpoints of a side of a quadrilateral. We will declare the statement of the result. The quadrilateral formed by joining the midpoints of the sides of a quadrilateral is a parallelogram. We will take a quadrilateral. We will take the midpoints and we will try to prove that this quadrilateral EFGH is a parallelogram. Many ways of proving it. We can prove that the sides or opposite sides are equal, the opposite angles are equal, and the diagonals bisect each other. Now the child can take any of these results and prove that it is a parallelogram. They can come and drag it and then check out whether the property always holds good for the quadrilateral inside. That is a parallelogram inside this quadrilateral. Let us try to prove this one or design this worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet. I have taken geometry view. In the option rounding off to 2 decimal places, labeling new points only. Normally, whenever you are making any worksheet, it is always better to make statements and ask the children some questions so that you can explore the ideas of the children. Now we have to tell that we are going to take a quadrilateral and then we are going to get a parallelogram out of this quadrilateral. We have to tell the result and we are going to draw it here. We have to design a worksheet and we are going to prove it. Parallelogram by joining the midpoints of a quadrilateral. Once again, let me tell you the statement. The quadrilateral formed by joining the midpoints of the sides of a quadrilateral is a parallelogram. Okay. Now the child can understand now. Okay, we will start doing it now. We will take a quadrilateral, roughly A, B, C, D and A. Okay, well, the quadrilateral has come. Now you can move this, you can move this C, you can move anything and you can bring it to any place. Let us try to take the midpoints of the sides of this quadrilateral A, B, C, D. We'll take it in order. We'll go in order. Let us take the midpoints. What you have to do in the midpoint? Simply either you touch the 2 points or the segment. Or I will touch this segment AB. I got the midpoint. Segment BC. I got the midpoint. Segment DC. I got the midpoint. Segment AD. I got the midpoint. You can touch the 2 endpoints also of the segment so that you will get the midpoint. Okay, well. Now I got 4 points now. I will go to this polygon now. I will draw the polygon E, F, G, H and E back. Okay, now we have to prove that whatever we have found here, a quadrilateral at the middle, it is a parallelogram you have to prove. Now what you can do is you can select it. If you want to make little bit colorful, you can show it to the children. You can take the style of it, little bit thickness you can give, and line opacity also you can have, and little bit opacity you can give, so that it will be little bit clear that there is a quadrilateral at the middle. Okay, now to prove that it is a parallelogram, we may use any of the conditions that we can go for its sides also. For I will first go for the side EF. Let me right click it. Go to the object property, go to this basic and go for name and value. Again click it, name and value. Actually, remember this getting the distance, there are two ways of doing it, but I am giving you the way which will be very easy for you to go in very quick, very quickly you can get it. Okay, well, now you see you got this 7.85, 6.88, 6.88. Remember, if you convert it into rounding off to one decimal place, it will automatically become 6.9, 6.9, 7.9, 7.9, and so on. Okay, now this property, another property is there. Okay, anyway, before let us just go for first analyzing this property. Okay, EFGH is a quadrilateral first. Okay, it is a quadrilateral. Now we have to prove that it is a parallelogram. For that, let us try to write actually what is EF. Sorry, EF is equal to GH or HG, whatever may be, is equal to, now the value is E and G. Either you can take E or you can take G, whatever you want. You just put it and then click OK. Whenever I'm moving, this will also move. Similarly, there is one more equality is there. That is one more opposite side is there. That is you are having EH is equal to FG is equal to. Now you are seeing here H and F are both are there. Therefore, either you can take H or F, whatever you want you can take. Okay. Okay. Therefore, what you are assuming here, that opposite sides are equal length. Okay. Now let us go for its angle property also. Now go for these angles. Good. Simply click the angle. All the angles will automatically come. For all the angles have come. Now you are seeing over here, the opposite angles are equal, and then you are having another property also. When you add the consecutive angle, you will get 180 like that. Okay. Now let us just go for opposite angle. We will make that statement over here. Therefore, in the text, you can go for this symbol. There is a angle symbol is over here. If you are selected once, it will come automatically. Therefore, angle E is equal to, then again go for the symbol. Angle E is same as angle G is same as, from this you have to take alpha. From here you have to take alpha. Okay, okay. Therefore, one pair of opposite angles I have mentioned over here. Another set of opposite angles I can mention. Therefore, I can go for this symbol F, EF. Okay, angle F is equal to angle H is equal to. Now from this this one you can take beta. Okay, now you can very well see here the opposite sides are equal and the opposite angles are equal. Now these two are actually required to prove that EFGH is a quadrilateral. Suppose if you want to prove that the very important theorem that when the diagonal bisect each other, well, that also you can prove. That I'm just going beyond that. Therefore, just you go for first diagonal number 1 and then go to diagonal number 2. Is it okay? Then you go for the point of intersection. The point of intersection of these two diagonals, the diagonal number 1 and diagonal number 2, it is meeting at Q. Is it okay? Okay. Okay, 1 minute. Escape. Okay. Now I will go for this point of intersection. Okay. Now I am going for this point of intersection. These two are intersecting. Okay. Sorry. Okay. This is a bit being something is getting copied. Okay. Well. Now point of intersection. I will take this line and this line. Okay. I got Q. Now I can go for this segment now. The segment number 1, I can go for EQ. I can go for E and this. Again, I can go for these two, H and Q. I can go for this and this. Okay, well, now I got this most probably. Now what you can do is from this graphing, you can get their values. You can at the bottom, you see it is coming as 5.5, 5.5, 5.5. Therefore, what you can do is you can go for this object property and you can show its value. It is showing, okay, to its value. Then again you can come back and then again this can be selected and you can show its value. It is 5 and 5 it is showing. Here you can come back and object property once again and ask it to show its value. It is showing 5.5. Again click it and then show its value. Okay, now it is very simple now. Now it is LMNN. Okay, now I think you can go for it. In the text box, you can write that there are, you can have EQ, okay, is equal to EFG. Therefore, GQ is equal to, now it is 5, it is K. Therefore, from this object property, you can take that K. Okay, now it is okay. Now it has come now. Okay, another one also you can write if you are interested. HQ is equal to FQ, which is equal to, from the properties it is M. This M, therefore 5.5. Okay, therefore now you can make statements, go on making the statements to prove that it is a parallelogram. Therefore, you can tell that in EFGH, actually what are happening, you can note down one after the other. That is number 1. Okay, one I will write opposite sides are equal in length. Okay. Okay, one thing I have just made, opposite sides are equal in length. Okay, another one also I can make the 2, number 2, the diagonal bisect each other. There is a very famous theorem. If the diagonal bisect each other, that also we have proved, diagonal bisect each other. Therefore, we have come to the conclusion that EFGH is a parallelogram. EFGH is a parallelogram. It's a parallelogram. Now, you see, now you can ask the children to come and drag it. They can get so many values, but these properties will not change. The property that the opposite angles are equal, the opposite sides are equal, that it will not change. Therefore, we have proved that a quadrilateral formed by joining the midpoints of the sides of a quadrilateral is a parallelogram. Let us learn to lead. Thank you.